There's a lot on our minds right now. Some of us have show fatigue with back-to-back-to-back events. Some of us walked into very cold weather and moving from spring or near summertime to the cold winter of Detroit. I get that. I get the economic turbulence affecting our lives, or possibly. And I get that some of us may be worried about our jobs. Those are all good reasons. What's not a good reason? I fear that the lack of gee whiz, oh wow innovation being discussed and shown on the show floor may be part of it. That we don't have that headline news and have you seen the latest and greatest? But I don't want you to be muted and be sullen and be quieter because of that, because I think it's something to celebrate. Moving from all this raw innovation just for innovation's sake into solving real-world problems, addressing the needs of the users and the application at hand is what we're seeing the industry do now. And that is not headline news. Process improvement, adding capabilities to allow you to do more. I think that is a sign of maturity for our industry, and I think it's something to celebrate. So here's my audience participation. If you agree with that premise, on my count of three, please give me a loud, verbose, oh yeah. 1, 2, 3. Oh yeah. There we go. Excellent. So please do me the favor of helping lift the spirits of others to keep things elevated, to keep it an additive manufacturing event. So as the voice of God said, I'm Todd Grimm. I'm here as an event advisor for Rapid TCT, and they've tapped me to be your tour guide, provide some highlights of the day both on the program and also what's on the expo floor. In the program, I got to start off with a very administrative item. Slide, please. If you have not downloaded the SME Plus app to your device, please do so, because everything about this event is contained in that app. Who's speaking at what time, who's on the show floor, what zones do we have? Download the app if you have not already. Now, other highlights. We have 2 sessions of executive perspectives. You're probably here for the 8:30 to 10 o'clock on printing for patients rather than for me, so you already know that's coming up. At 1 o'clock, we have one on geopolitical impact on additive manufacturing, a timely conversation. On the show floor, lots and lots of activities. We've got the SME Theater, where 5 industry partners are making presentations, including Additive Manufacturing User Group, or AMUG for short, on talking about leveraging cross-industry knowledge to benefit yourselves. We've got one on strategic networking for your career growth, and 3 others, which I cannot remember off the top of my head. We also have SME's Mission Critical Workforce 2030, an interactive area on the show floor to elevate the conversation on the skills gap and the workforce challenges that we have and may be facing, allowing you to have a readiness assessment for your company, turn around and use a think tank for consultation to help you plan or help your company plan, and also to elevate the conversation. Now, we're going to have one of the favorite activities of the event for the last several years. Tonight's Additive Manufacturing Industry Celebration is at 5 o'clock, and it's right here in this room, if I'm not mistaken. Definitely plan on being there. Don't run off and go do dinner with 2 of your friends. You will see hundreds of people in this room being fed, drinking beverages, and having live entertainment, all while we're making new connections. So please, don't miss this evening's Additive Manufacturing Industry Celebration. Now on to what's new or interesting that I saw as I worked the show floor yesterday. I'm going to start off with dental. First off, an apology to all of you in healthcare, in the medical arts. I'm an industrialist, and I usually don't talk about medical, dental, and related very much, so I've done it a disservice. I'm going to try to make amends here with 3 highlights. For dental applications, you've got post-process technologies with 2 new post-processing systems. These are automated systems to drive out the labor and also ensure conformity time after time after time. The DEMI X520 is specific to support removal for PolyJet for the dental labs. And even newer, just announced in the last couple of days, is a DEMI X200. And that is I love the term, chair-side all-in-one post-processing unit for any VAT photopolymerization. So a small unit fits in maybe a small dental lab's workflow. You clean, you cure, and you rinse. Then we go to Carbon, add-on capabilities to their line of 3D printers, specific to dental, APP, automatic part or print preparation. So that's streamlining the front end. And then also, this one's interesting, and I don't have the details on it, AO polishing cassette. What their claim is they're actually polishing the surfaces of these dental devices, dental appliances, during the 3D printing process by using a light scattering technology. And then finally, 3D Systems with the NextDent 300. This is for dentures, and its claim to fame is fully cured dentures coming out of the printer that can be multi-material. And for those of you in the dental world, you understand the term, and monolithic. Monolithic meaning we're not taking one substrate and bonding another material to it in a secondary process. As you can see right there, is that innovative and breakthrough and you're going to go home and tell your wife, children, husband, grandparents? No, but it improves the quality of life for us as users. Then we have reinterpretations, deployable systems, point of need. Snowbird Technologies and Additive both have containerized additive manufacturing solutions. Snowbird with their SAM, Snowbird Additive Mobile Manufacturing Unit. Their newest version includes additive in both metal and plastic and also CNC machining. So a 10-foot mill van housing everything you need. Trot it out to wherever you need to do repair, replacement, or prototyping, and you've got your tools. Additive introduced the latest version of their containerized solution called AmDroid X actually, X for Expedition. And theirs is taking and elevating previous solutions, first off by raising the roof. Literally the roof raises once you're in place to give you more Z height. So you have a build volume, robotic arm-based DED with about 1.4 by 1.4 by 1.4 meters. Interestingly, it also has an onboard control center. It has 4 power walls on it, which are rechargeable by solar energy, so you can drive these processes without it being plugged in, and other capabilities. Now I'll go into metals. Caracol, which is known for large format, plastic-based, polymer-based 3D printing using robotic arms, is now in the metal game. They've got a solution called Vipra AM. So this is DED also on a robotic arm, 9-axis motion. So not only the usual motion of a robotic arm, but also translation down a track to make really, really massive parts. As I said, they're using DED, but they use 2 different flavors. You have the option of going plasma arc for the energy source or cold metal transfer. Who else? Now I'm trying to remember who I wanted to talk about. Renishaw, another quality of life improvement, OSV, optical system verification, giving you, the user, when you want to, at whatever intervals, the opportunity to dial in and confirm laser power, laser spot size, and scan fields. You run the automated routine, and you get the information you need to tweak those knobs so that you get high-quality parts out at the performance levels that you're expecting. And then finally, for metals, this is a software solution. Pan optimization, I didn't know they existed, discovered them yesterday. It's simulation in advance of doing your metal 3D printing. They've got a solution for laser powder bed fusion and a solution for DED. I was really, really impressed. On the front end, they've got a very sophisticated modeling tool to create the mesh. And their claim, and I believe it, is that they're able to create meshes on very dense, complicated geometry that other systems would choke on. They then take that information and using the parameters that are going to drive your process, look at thermal and mechanical issues to see what possible defects could happen so you're closer to or achieving first time right. Or if you've tried to build 5 times and it's failed 5 times with 5 different sets of parameters, you can run it a little after the fact, run it and figure out what was the root cause of the problem. Then in polymers, Juggerbot 3D, They've got the Tradesman P344. These are large FGF, fused granulate fabrication machines. The Tradesman P344 is not new, but the Astra version is. So if anyone here wants to print large PVC parts, take a look at Juggerbot 3D. It's got corrosion-resistant components internally, and then also it contains the nasty, nasty fumes that come off of PVC when you're melting it. And the part that's in the booth, about yay tall for oil and gas. Others on the polymer side, Arberg. If you don't know Arberg, they're doing polymers, but they're using basically a small injection molding machine in the device to melt the material and then spit out droplet by droplet of material. They've got a new machine, the 550-3X, again, addressing user needs. It is a more affordable version of the 750-3X to satisfy the needs, wants, and requirements of the marketplace. And what really caught my eye, something called Justica Planning Assistant that's embedded with this machine. Justica's goal is to make it so that a novice user can print good parts right out of the gate, so it's doing all the heavy lifting. And once you've got it dialed in, then use Justica to optimize the print process to get the most out of it. And then Photocentric. They started the use of LCD with photopolymer resins years ago, and they just keep coming out with new interpretations that are quite interesting. One, I don't think anyone's going to space, but you might want to talk to them about the Cosmic Maker. Able to print in space liquid resin. They're using centrifugal force to keep that resin locked down so the machine can print in any orientation. It uses a node off their most recent machine called Jenny, which is a modular node-based solution where you can customize it by picking the print node, what wash node, what cure node, what clean node you want, and then the whole process is automated with a vertically oriented or vertically operated robotic system. Those are just some of the highlights in my mind. Most of them, again, are in the mundane side, but they are improving our quality of life. So as you go through the balance of the day, we've got a lot to see still, a lot to hear in day 2 of Rapid plus TCT. But as you go through your day, I'm asking that you, or challenging you to, walk the floor and hear the conversations with open mind and open eyes. Don't let the mundane pass you by because it didn't look interesting or gee whiz. Have your thirst for discovery. Be backed by that to discover the solutions that are going to improve your additive manufacturing implementations. And finally, got to dig a little deep on this one. When you're in the weeds, you start to become numb to the great things and the exciting things about your world. Try to do your best to recapture that spirit of those that have just entered the additive manufacturing market and still see that we are doing absolutely fantastic things. Ladies and gentlemen, I thank you very much for your attention. I hope I provided at least a few tidbits or nuggets that help guide you through the balance of the day. Thank you very much.
Additive manufacturing is impacting everything. Everything we touch, everything we see, hear, drive, fly, light, build up, tear down, and build again. Every part of our lives. Industrial 3D printing and additive manufacturing. As powerful as it is flexible. As sustainable as it is customizable. And for 35 years, SME has gathered the greatest and boldest minds, the titans of industrial 3D printing and additive manufacturing, and built a strategically located premier event that's one of a kind, Rapid plus TCT. This is where the additive manufacturing community of leaders, emerging startups, and vital suppliers come to showcase innovations, insights, and solutions, and discover new ways for the world to travel safer, live longer, learn better, and advance faster than ever before. Rapid plus TCT is where business gets done, and so much more. It's a vibrant landscape of collaborators and groundbreakers, where big ideas are sparked on our show floors and products are launched into today's most sophisticated applications. With a mission to develop a web of connectivity for key industries, Rapid TCT brings together OEMs, businesses, manufacturing, and people from across the globe to provide solutions in manufacturing like no one else can. Join the innovators and trailblazers of industrial 3D printing. Be part of the solutions to tomorrow's challenges at the only event of its kind, and connect with the people and industries who build the world. Rapid TCT, the solution for additive manufacturing. We pursue new markets and attract new customers. That's why Rapid TCT announced its North American tour, rotating to key geographies to advance and accelerate the adoption of AM. This is a must-attend event. Rapid TCT.
Please welcome Executive Director and CEO of SME, Jeannine Kunz, and the Executive Director of America Makes, John Wilczynski.
Good morning and welcome to our second day together here at Rapid TCT, AeroDef, Manufacturing, and SME Fusion. WCX and TRX, 5 things going on. I call it like an event palooza. I hope you've enjoyed the events and activities so far. For newcomers and those that have been around for quite some time with us, I want to start with telling you a little bit about who SME is. SME is a nonprofit organization. We were actually born here in the city of Detroit area almost nearly 100 years ago. And I was telling a story last night at dinner about how our mission and how we came together was 33 tool engineers joined forces to do something bigger than themselves, something that they needed, that they thought was an imperative at the time. And here we are almost 100 years later, sitting here, listening to the video behind the screen here, and thinking about how this community has come together to bring forward what is needed for additive manufacturing. So coming together under common causes to do something bigger than any one organization is kind of what you guys are doing here today. SME's purpose is to advance manufacturing, to drive competitiveness, resiliency, and national security. And the way we do that is we go about it by accelerating the awareness and adoption of advanced technologies like additive manufacturing. In tandem with that, we really look to build North America's talent capabilities. We believe that those two, when done together, advancing technology and advancing people, that's where we really create true innovation capacity and capabilities in our individuals, in our companies, in our communities, and our country. SME is committed to driving meaningful change to support the industry's long-term success. And this will require continued and even more collaboration with like-minded organizations, such as my dear friend, John, at America Makes, who has been one of our long-standing and valued partners. I have personally witnessed the alignment between John, his team, and the organization in our efforts, and I'm confident that we will continue this working relationship just like those tooling engineers did almost 100 years ago to do something bigger than any one of us. John?
Thank you, Jeannine, and hello, everyone. Good morning. Welcome to day 2. It's wonderful to be here today at Rapid TCT's 35th occurrence. So, to think about how this community has really come together here in Detroit again, in the home of the arsenal of democracy, which has been a key player in the industrialization throughout the 20th century. Ourselves as a convener of government, industry, academia, the workforce, and economic development organizations, America Makes also works on accelerating additive manufacturing adoption while supporting the U.S.'s global competitiveness. Much like our strategic partner with SME, we offer a collaborative, non-competitive environment where our members come together to work on impactful programs, much like projects that Cleveland State University is currently doing, working on assessing the feasibility of employing different AM techniques to streamline the production of low-volume forgings. Or Alaris Defense, who's working on developing an automated workflow for wire feedstock-based AM that can also function across many different platform systems or working environments without requiring major modifications to the equipment. So all of these projects benefit the United States Department of Defense. And that's really where we've concentrated over the last 13 years. America Makes has worked alongside Rapid TCT and really have grown our presence here. In fact, this year, this is the first time we've co-located an activity, so we hold a technical review and exchange twice a year, and we are co-locating, and we're bringing the shared additive research and development that we're doing at the Institute through our contracted program efforts, sharing with members and members of the AM community. We've also expanded, if you've not been to the showroom floor yet, or if you haven't got to this portion of the exhibit hall, we've expanded our presence dramatically here at Rapid TCT and brought 12 of our members along with us within our additive manufacturing pavilion. So we'd love for you to stop by and check out the pavilion today. Jeannine?
Thanks, John. Yeah, it's exciting to think, and it's all been done just only since 2012, right? Every time our communities collaborate, we're reminded of how our efforts are complementary versus competitive. You know, it's one of the things SME is really very focused on is how to come together to do something, as I mentioned, bigger than any one of us can. And I really have enjoyed that journey, and as you've talked about. We valued this partnership, as I said, since 2012. We were helped actually stand up the first Manufacturing USA Institute on additive manufacturing. As we know, something SME has been proud to be engaged with for almost 35 years. So when discussing technology, I heard Todd share with you, we've also talked about how technology and talent, how SME believes these are the two things that SME can do to help advance manufacturing together. So this show is rich with technology, lots of great conference sessions and information, things about application, roadblocks to technology adoption. And Todd mentioned the area that SME launched here, which is called Mission Critical Workforce 2030. And we really did that in the back area right next to America Makes to provide any of you solutions that might be related not only to technology, but to talent. So again, if you get the chance, certainly stop by. Our team is happy to help and learn from you on what you need from an organization like SME to further advance what you do and how we can support it. So when we think about coming together, we're really proud, again, John, for the work we've been able to do with America Makes. Part of that partnership, as I mentioned, was helping stand up the Institute many, many years ago. We'd work on programs like our certifications together and the competencies that are required, doing grants together, and now to see us really amplifying how we can work together here at Rapid TCT. So thank you for all the continued relationship and partnership that you've had with SME. We're committed at SME to stepping up and engaging with you as an industry and seeing how we can better serve your needs. Thank you very much. I'll turn it back to you, John.
All right, so thanks, Jeannine. So it's now my pleasure, we're going to kind of get into the show. It's my pleasure to bring to the stage our first panel. So the first panel today is called Printing for Patients, and it's going to focus on how 3D printing is shaping the future of healthcare. Thank you, and please enjoy the show.
Please welcome to the stage today's Executive Perspective panel, Laura Griffiths, Head of Content, Rapid News Group, John Davison, Acuity, and Nick Estock, Deputy CEO, AddUp.
Welcome to another Executive Perspective session. We're going to do something a little bit different for this morning for the healthcare session. Instead of a panel session, we're actually going to do 2 fireside chats with an additive manufacturing OEM and an additive manufacturing end user to really share their story of collaboration and, most importantly, applications. I've spent the last few weeks getting to know each of our speakers, and even if you're not necessarily operating in the healthcare sector, I know there's so many universal learnings that you'll be able to get from each of our speakers today. So let's get into it. Welcome, guys.
Thank you.
Great to have you both. Let's start at the very beginning then. So when you guys both met, companies came together, where was Acuity really at in its AM journey? How were you kind of procuring your parts? What were the challenges you were already facing?
So historically, we'd used a third-party manufacturer overseas. The timeline to get products, into the United States, as well as the R&D timeline, was a bit of a challenge. We knew as we grew that, and I don't want to steal your thunder from a question later, that we needed to tighten up our timelines, our schedule, and certainly the expense.
Mm-hmm. And so also for AddUp, I mean, where was AddUp really at this moment in time? Had you worked with many customers in the healthcare session when you came together?
Yeah, we were still learning, right? And so we were learning through our customers. We were learning through our team. So we have a solution center in Cincinnati where we help our customers adopt this technology. So we went and we rebuilt the teams. This is early days for us, 2021. We consolidated our facility into Cincinnati. We rebuilt a team, and we hired a medical advisory board to help us understand the challenges in the healthcare sector. So our machine was originally designed to support large volume, high scale applications specifically for tire molds. That's part of our pedigree, being a joint venture founded by Michelin and FIV. And so we knew this machine, this technology could help the healthcare sector as it's growing in adoption and accelerating in high volume throughput, but we didn't quite understand the challenges of the healthcare space. And so through our advisors, hiring the right folks to be a part of our team, working with our customers, we started to understand this market and understand how we could help.
I think that's something key that came out of yesterday's executive perspective session, that it's really not about thinking of the industry or the technology as a whole, but really kind of honing in on those specific application areas and learning what those specific sectors really need from this technology. And so what we're talking about Acuity and the healthcare solutions for spine surgery. Can you talk a little bit today just about those specific applications you're offering and why AM is such a good fit for this particular?
Yeah, so unlike some of the other industries, we are lower volume with a high inventory load. So that means that we need to be very, very careful with how we make our products. And traditional machining, in order to hit the price points that we need, you're ordering units in hundreds and thousands of units at a time. Additive allows us to order far less units at a time, carry far less inventory, which of course is the goal of every successful business.
So let's talk about the process of actually working together then. Can you talk us through that? Why was AddUp the partner of choice for this particular application? How do you guys work together?
You want to take a stab at that first?
Yeah. Well, it was actually funny. We were talking in the back, right? And one of the things we were thinking about talking about later, right, is what is the difference between how the OEMs and people in this hall tend to think about this technology versus how the end users. And John isn't passionate about 3D printing, right? He thinks it's cool and he likes us, I think. But his goal is for patient outcomes, right? Is to utilize this technology to get parts that help patients. And so, I think that's really the key that we need to understand is this is just a tool for us to get outcomes, right? And so, John, being a great partner, is helping us learn some of the challenges that they face, and we get to help him utilize this tool so that he can get that end result that he's looking for.
Yeah, Laura, we looked at several of the other companies, and each different company certainly has its advantages, and one of the major advantages that we saw in AddUp was its ability to actually create high production volumes on their build plate. Super interesting to us because we can get a lot done in a short period of time and leave capacity available for R&D. So the high definition products is also the utmost importance with medical too, to have tight tolerances.
Okay. And I think from talking to you both over the last few weeks, one of the most interesting parts of this story is the fact that we're talking about an SME application here. And I think there'll be a lot of people from small, medium enterprises in this audience today wondering about how additive manufacturing really fits with their journey. Can you talk a little bit about Acuity from that perspective and any challenges maybe you faced in adopting additive to start with?
Sure. All of our products, this is a medical breakout session, regulated by the FDA, and they require a certain level of scrutiny. I'm sure it's in other industries as well, but holding tolerance is always a challenge, especially when you're printing. And so you really, your first choice has to be a machine that can hold the tolerances that you need. We also want to limit post-processing, the best that we can. And so when we're choosing those things, you got to choose for the types of products that you have. Ours, in the medical space that we're in, spine, we're talking about porous metal products that we want quick on-growth of bone. So we usually have a porous structure. We're using different softwares to create those structures and making sure that the machine is printing those effectively and consistently is a primary goal.
Okay.
Just to add to that, one of the challenges I think you guys face with the adoption of this technology, you could utilize third-party services, right, to utilize the technology to get the parts you were looking for. But for you guys to vertically integrate this technology really to have the subject matter experts of understanding how to utilize the machines, how to get parts to come off of it, the process at an application. That's where I think the partnership really has its strength. Is I don't think the Acuity team could have done this right away all by themselves, right? And so partnering with us allowed us to accelerate their time to market, utilizing our machine at our facility with our team, leveraging their expertise in the application itself.
Yeah, it was definitely a collaboration.
And it's something that's really grown as well over time, right? I mean, you've gone from working together to really sort of optimize this, and now you've brought this technology in-house. Can you tell us about that decision to bring it in-house and what that's allowed you to do?
You know, Nick alluded to it a second ago. I think 3D printing is fantastic, and it's been very beneficial inside of our company. I don't sit around and look at the machine and salivate over it. I'm really looking for the products to come off that we can bring to market. All that said, the decision to bring it in-house really was a measure of us wanting to control our destiny. And when you're a small or medium-sized company, you're oftentimes at the back of the line with some of our larger competitors, Johnson & Johnson being one of those significant competitors. So when you're competing for space on other people's machines, the easiest way to solve for the problem, buy the machine.
Yeah. And it's the Format 350, right? So tell us about that specifically then. What has that allowed you to do, I guess, from both of you?
Yeah, so I mean, again, it's a large industrial machine that was really defined by Michelin. So when our company was founded, Michelin was the driving product definition, and Fives is a 200-year-old machine tool builder that knows how to make industrial repeatable machines. And so that machine's 350 by 350, so it's a little bit larger platform than most medical device 3D printers. It's got 4 lasers, and so it's really perfectly suited for high volume applications. So Spine has adopted this technology most rapidly compared to some of the other applications in the medical device, and the machine's perfectly suited for high volume applications that the spinal segment needs.
And so you mentioned a little bit then about bringing this technology in-house and touching on, I guess, that's sort of the supply chain advantage of it, really. You can really manage everything yourselves. But I wonder if by having this technology in-house, has that also changed the way you've been able to innovate on your products? Have you been able to do that a lot more quickly? Yeah,
my VP of engineering is somewhere in the audience there, and he can attest to the fact that when you're going through iterative changes during R&D, there's a lot of waste. You're learning, you're figuring things out, you want to test. And when you're sending those things out and you're dealing with 6-week lead times, or worst case 12-week lead times to get on a machine, you get your parts back, and the powers that be investigate them and make sure that they're good, accurate, or how we can define, further define the end goal. It makes it a lot easier when I can jump myself in line, because it's my machine, and we use R&D very, very rapidly. We can skip the line, get our products back, iteratively change, and then it's back for another change. The timeline is probably the most important piece to that. One of the things that we talk about is, if something takes us 18 months to make in a fast follower scenario, it's worth $0 in the business. If I can get it to the market in 6 months, I can actually penetrate the market, gain some market share, and it's worthwhile. So the expense of the machine is really offset by how rapid we can develop new products. And as you allude to, the R&D piece is very, very important.
I think you've just touched on something quite key there as well, and we talked about yesterday in the opening panel session just about additive value there. You mentioned you've got the cost of the machine, but it's about finding value in different ways, and I think that can be in rapid iterations, being able to have this in-house and being able to really take control or whatever it is you want to do. Do you think maybe we need to think a bit differently about how we prescribe value to additively manufactured parts?
Sure. I mean, it's very challenging in a small business like we have to justify the expense of a machine, dollar for dollar. The soft value really comes from, as you say, that exchange of the speed that we get. If you want to spend all the money in the world, you can use third party. There's machines out there that are available that you can get time on, and you're at risk of them going on vacation or a machine going down and not having a backup like we have in Cincinnati. So you have to find the value in other avenues, as you said, and I spent probably too much time on it already. The process of R&D and going through 10 or 12 iterative steps, prototypes, it's a lot quicker when you get to decide that tomorrow we're going to put this on the machine.
Nick, is that part of the conversation piece for you with customers?
Yes, right. So I mean, there's a couple things that they're really benefiting from, and it's hard as an OEM for us to be able to help quantify those. So we're trying to help build a business model or a business case for our customers to say this makes sense for you to internalize, and it's hard to quantify those things. But the Acuity team, right, understands that yes, time to market is important, as John was saying, so they can rapidly iterate through their R&D. They can obviously consolidate their own manufacturing so they're not paying a premium to others and standing behind others through third-party contract manufacturers, but they get to control their inventory too. So that's a big carrying cost to be able to have to hold when they do make these orders through contract manufacturers as a smaller outfit. They're going to have to order in larger volumes and carry that inventory because they don't know how long it's going to take to backfill that. So being able to manage their inventory more effectively is a big carrying cost that they have direct control over.
I can add to that as well. There's a financial piece to that we probably haven't discussed, and that is carrying those finished goods has a tax burden on the company, and when you can carry them as unfinished goods in inventory ready to go that need simple steps to finish, it's incredibly helpful from a tax perspective as well.
That's interesting.
Yeah.
And this is a healthcare session, so we can't really not talk about the regulatory aspects of it. And I know you both have very interesting perspectives on this. So Acuity, you've received FDA approval for your printed spinal and body devices. And can you talk a bit about going through that process? Was it challenging? What kind of steps did it require? And then Nick, I know you've got kind of interesting opinions on the fact that this may be a little bit of an overblown challenge that we talk about in this industry.
I can jump in first. I'm not obviously in the day-to-day. I get the bits and pieces of it along the way. It's a very stepwise process and not terribly complicated, and it's perfectly outlined. The tests that you need to do and create and the parts that you need to make in order to be tested. So I don't think that it's terribly complicated. It can be time-consuming, and it's not even terribly expensive either. But let's hear your version.
Well, I think that's exactly right. I think for a lot of folks, this is a new technology, and so the qualification aspect can be kind of intimidating, right? And it doesn't have to be, right? If you have the right partners, you have the right folks that understand the regulatory process, it doesn't have to be. And the FDA has done a really great job of trying to understand this technology, writing out very specific guidelines on how to utilize it. And so it's, as John said, there's a plan out there to walk through your IQ, OQ, PQ process, through the regulatory process, that can get you to your end goal of FDA cleared device. So it doesn't have to be as intimidating as I think some people in the industry might initially think it is.
Okay. Is that something as an OEM that you've had to kind of get to grips with and learn about, or does it really affect what you do from your side?
No, I mean, as I mentioned, right? I mean, we've been learning along the way through this process, and so that's why we brought in the team on our staff that understand that process. That's why we hired our medical advisory board to help us understand these regulatory and qualification aspects and challenges. So yeah, it's been a learning process, and as we've gone through it, we went through the ISO certification at our facility as well. So once you walk through it, it's the big scary black box isn't quite so scary, right? There's a way to step through it.
I want to talk a little bit more about the collaboration. You said you've really built this partnership together, and I know when we spoke a few weeks ago, you talked about kind of you've done this application now, you've kind of created this pathway for what can come next. What do you think that sort of looks like in reality? Do you feel that we are on the cusp of some great change happening between additive manufacturing and the healthcare sector?
I think we're already seeing that. The reason why it's not terribly complicated to get these products approved now is because it's not novel anymore. When we started making our product 10 years ago, there was some novelty to a printed spinal device, and now every major manufacturer has multiple different products that they're utilizing 3D printed parts. So from that aspect, not terribly new. What we're seeing more and more now, and I don't want to steal the thunder from a talk that's going to be later, is patient-specific implants. Those are coming on board. I had a surgeon tell me many years ago, we traditionally make parts in 1 or 2 millimeter increments, and in this particular part at another company, we were in 2 millimeter increments that were even sizes, and he told me that God made odd-sized people too. And I think we're taking that to the next step, given that we can now do patient-specific parts.
Yeah. And Nick, what about you from your point of view?
Yeah, so I mean, it's really interesting. In previous roles, I had less exposure to the healthcare sector and more on aerospace and defense, and certainly that's a rapidly growing industry within using 3D printing. But the medical sector has much more rapidly adopted and has been using this technology for quite some time, right? And so spine is certainly the largest adopter. John, you said probably around 40–50% of spinal cages now are 3D printed. So it's a huge number that we don't always focus on or remember in the 3D printing industry is healthcare's been doing this for a long time, right? And so we're seeing this now transfer to other applications within the healthcare space, hip cups, knees, but then much more broadly, right? You actually see the aerospace industry and other industries adopting some of their qualification protocols that the healthcare sector has really paved the way for this technology to be more broadly adopted.
Mm-hmm. I want to pick up on something that was mentioned in yesterday's opening session, and Todd kind of asked the audience to put their hands up on whether they felt they were being served by, whether end users felt they were being served by additive OEMs, and I don't know whether they necessarily got the answer that we wanted in the audience, but you've described here a very clear partnership. It's not really just an OEM customer sort of experience. Can you just talk a little bit more about how that actually works in practice, what it's like for you two working together, and how you work together, how you listen to each other, how it impacts what each of you do?
I think our relationship is going to be different than relationships you'll have moving forward, in that we both had to learn along the way. And the FDA has and continues to refine their process on how they want to look at three-dimensionally printed parts. And so the process that we're going through is very, very collaborative. I know that Nick and his team is on the phone with our engineers likely several times a week discussing these topics and trying to figure out how we can most quickly get these products through the FDA. Mm-hmm. All that to be said, once it's done by us, we are now the new reference for the Add-Up 350 machine, which makes it very, very easy for the next guy to come along, and you're welcome to anybody that chooses that platform.
We leverage each other's expertise, right? And so what our team knows is we know 3D printing, right? And we have some skill set in our office that understands how to do it for medical devices. But we don't understand what is uniquely, intricate or what the part is actually designed to do, right? So Acuity is the design authority, and we leverage their expertise on how this medical device is being used, what surfaces or features are critically important for them and their customers, their patients. And we understand how to adopt our process to make sure that they're getting those best possible parts and therefore best possible outcomes. So leveraging each other's experience and learning along the way, it's been a great partnership.
Mm-hmm. And I said applications at the start. This is all about applications and how additive manufacturing is really being used out there in the real world. So just tell us a bit about what are some of the most meaningful outcomes that we're seeing so far.
Really, the surfacing was the first thing that I think was critically important. We've changed materials, whatever the new is in medical has changed over time, and we continue to come back to titanium alloys. They're readily available, and now that we can print them, we can actually make them look, feel, and act like bone. Mm-hmm. Our body accepts that alloy, and certainly it accepts the 3D structure that we're able to print now at high resolutions. So I'd say that moving forward, being able to utilize that technology for more traditional medical parts, plates and screws, certainly the advantage in having some of that porosity calculated and built into the products is important. I think it'll benefit patients. We have to get through the testing pieces to ensure that we'll have the same outcomes and the same strengths. So even at dinner last night, Nick and I were discussing a new product that we're creating, traditionally used on 5-axis machines. We're going to try to print it and see what we can do, and he already had some strategies on how we can best lay it in the machine so that we get the most optimal outcome.
Nice.
Yeah, I mean, I think as you get through the process, you start to understand how you can leverage this technology on other applications, right? And so looking at new applications, obviously in the healthcare sector, but even beyond, we can leverage the lessons learned on surfacing techniques or developing different processes or parameters to optimize certain features that can be applied elsewhere. So, we're learning along the way.
And I do think healthcare very often is probably the best area to really show the advantages of additive manufacturing, because it's something that we can all really relate to. It's something that touches all of our lives. So can you tell us a little bit about the actual end users then? Just tell us about how the success stories that you're perhaps seeing with these products.
Sure. In December of 2023, I became a patient of my own product. I had back surgery. One of our cages is at my L5S1 level. So hadn't. Good question. So it was a good experiment for me to be able to walk along and make sure that we're seeing what we thought we would see. Our hypothesis when we began 3D printing in the spine space 10 years ago was, what is our advantage going to be? The biologics do a lot of work. If you're interested in the medical stuff, we can go into more detail. But the most important feature was that from an additive perspective, we wanted to create an environment where we had some advantage over the products that were out there. Every business wants that. And our story was going to be this speed to fusion. Fusion rates in spine surgery, pretty consistent across the board amongst products. But if we can create a surface technology where the bone can grow onto it and ultimately through it, we can get patients back to their normal everyday lives a lot quicker. And that's the strategy for every surgeon and certainly for every patient. So I'd say it was ill-advised, but I felt really good at 2 months, and I went snow skiing.
Wow.
After seeing my x-rays. My surgeon was not pleased with me, but we already saw signs of fusion, so I felt pretty comfortable that I could take it easy and go snow skiing.
And if AddUp isn't using that to advertise on YouTube, then you're just
Right,
very wrong.
right. I wasn't aware of this story, but yeah, we're gonna create John to be our poster here. So.
And I hear so often and walking around these trade show floors of 3D printing companies that are using their own 3D printed parts inside the machines, but you've definitely taken that to it. It's
a different level. It's a different level, absolutely.
Not just the hair club president.
And so, Nick, when you're meeting with potential users in the healthcare sector, other users who might be interested in using 3D printing, what kind of broader picture are you getting of the adoption of additive manufacturing in this space? I know we talked about the fact that it's here already, we're seeing parts in their thousands, but is it still viewed by some as a niche kind of far out there tool?
Yeah, I mean, I guess it depends who you're talking to, right? And so you're going to get a broad spectrum of opinions. Those that are less familiar with the technology certainly might still see it as niche, but those are the folks that are going to be left behind in the long run. So if they're still viewing the technology as still a prototyping technology, not a ready for mass production technology, they're going to miss the boat. The healthcare sector's obviously broadly adopted this technology. It's in production. It's been in production for decades, right? We're seeing our customers are coming to us because they see 3D printing as a solution to their challenge. And as I said before, right, people in this room, this audience is typically, we like 3D printing, we like to nerd out about 3D printing, but our customers are less inclined to understand 3D printing the way we understand it, and they're more inclined to understand how does this tool help me go find my solution, right? And so whether that's better patient outcomes, whether that's aircraft that are more fuel efficient, whether that's making tire molds that create tires that can maintain their tread wear or their traction throughout the tread wear of the tire, right? So our customers see this technology as a means to an end. And so I think having the healthcare kind of pave the way from a qualification perspective and understanding how do we control this process and make sure that we're getting good quality parts repeatably out of it is again now paving that way, and we're seeing a broader adoption from other industries.
John, would you kind of agree with that perspective from someone inside the healthcare industry?
100%. As we were going through the exercise of talking about this event, Nick and I were talking about what's really neat about the 3D printer, and I was like, I got to be honest with you, I think it's a really cool thing, but
I don't care.
Yeah, as long as it makes the parts like it says it's supposed to do, that's really the goal that I'm trying to achieve. So we let the people, them, when we talk about the collaboration, I'm going to throw it back to them. That's what they do. They're very, very good at that. And I want them to keep being good at that so that I can focus on the things that we do, which is make the parts and then deliver them to the operating room.
Okay.
Absolutely.
I think we're in quite a fortunate position today where we do have an end user and an OEM on the stage at the same time, because I think sometimes it feels like, well, for the longest time, it's felt like additive sometimes as an industry in search of an application, and then sometimes not necessarily thinking about the needs of the actual end user or end use part. So I want to get both of your perspectives today on what do you think some of the biggest disconnects are between developing AM technologies and then the people who are actually out there using them, and also is that getting any better?
I think so. I mean, again, it's just as it's stated there, right? Additive manufacturing is our hammer, and we're out there searching for nails to go swing at. That's the disconnect, and it's let's understand, and I encourage our team constantly. I don't want our customers coming to our site, because the first thing we do is we start talking about our technology and how cool it is and what it can do. But what we're not understanding is what their challenges are, right? So I encourage our team always, let's go to the customer site. Let's go understand what their manufacturing process is, what challenges are they facing, and then how does our technology become a solution for their challenges. So I think that's been the disconnect, but I think it is shifting, yeah.
John, what about you?
I mean, I'd reiterate that with one caveat. In the medical space, it's becoming the standard of care, and so it makes it very easy to adopt. I think in healthcare, we are actually looking for more and more applications to it. I told you we're looking at products that historically no one said that you could print. They were always a 5-axis, job. We're looking at printing those things now. We'll see what the FDA has to say about that.
Okay. And so what does overall success look like for you for this collaboration? Is it seeing that one patient, and you've done it yourself, with the successful part? Is it other products in development? Is there maybe, as you mentioned then, is there a key product you really want to get out there? And, is that looking a bit easier with your in-house capabilities now?
100%. So, I spoke to the R&D process being time-consuming and expensive, and in this world, again, to reiterate what I said earlier, if you're 18 months or 2 years out on an idea, you're guaranteed that one of your competitors is working on the same thing. It's the speed to the market. If you can grab some market share, you can hang on to it for a little while. If you're the 10th to market, you might as well not even done the project. So bringing that in-house, and I'll circle back to, managing the expense for a small company to take in one of these machines, it's certainly substantial. But if you look at the cost, the opportunity loss because you weren't able to rapidly get through the R&D process, I mean, obviously we've made the decision that we've made because we believe that there's value in the speed that we can attain and ultimately the savings over time.
Yeah. And Nick, what about for you as well? I mean, what does success look like there? Is it seeing more applications? Is it when the customer doesn't care that it's 3D printing technology?
Well, I mean, our success is their success, right? And so they're in the process of I think, having 4 devices go through the FDA and are pending clearance. So our success is they're able to get through this process and get their products to market more quickly, and then ultimately they're going to take this machine and bring it down into Texas and stand up their own operation, right? And so we were able to help them facilitate the adoption of vertically integrating this more quickly, right? And so we're already being successful, I would say. So they're in process of doing that. We have a really great relationship in which our teams, like John said, are communicating on a daily basis or multiple times a week to help them get through this process. And so that acceleration of saying, here's a company that wants to integrate this and couldn't find a pathway to do it that made sense for them as a business, and we were to help facilitate that with our team and our facility while they could stand up that operation. I think that's the outcome that is, I think we're most proud of.
And I realize time has very quickly run away with us now. And I know that maybe you guys had some things you wanted to share before we finish in terms of like slides and things like that, but I just have one last question for you. I just want to get a sense of, walking around a show like this today, I want to get a sense of your optimism around the potential of these technologies in healthcare. What's keeping you both motivated every day to keep working in this sector?
I mean, this is 100% of our metal sales is printed metals, so it's substantially important. And it's really how we have created a pathway in a very somewhat saturated market with massive competitors for me. So if you're going to have a niche, it has to be some novelty that you can stand behind, and over time it has to show a clear scientific advantage. And all the publications are beginning to come out in our space documenting. We are certainly in the process of gathering that information and publishing it as well, showing the advantages of this technology over former technologies, traditionally manufactured in different materials, etc.
Okay.
Yeah, I mean, I think if my team knows anything about me is I'm highly competitive and I love to win. And so where I see the wins is just when we find a solution for our customers, right? So that's what motivates me is my background's in engineering, and so when I can see this technology actually solve a problem it gets me extremely excited. So I love to go where our engineers are sitting and have them show me which applications we're printing and what it was doing and why this is something that's different for our customers that they're not able to get elsewhere on the market. So those are the things that get me motivated.
And in the last couple of minutes, is there a final thought you want to leave our audience here with today? Anything they should go out into the show floor really thinking about?
I think it's, this technology is ready for industrial applications, right? So it's ready for prime time. Our company's been founded on that pedigree, and we're ready to help our customers industrialize this and either vertically integrate it or work with one of our contract manufacturing partners so that they can broadly adopt this technology.
Mm-hmm. John, any final thoughts from you?
I would just say that for anybody out there that is me sitting in the audience, has a small or medium-sized device company, this technology, you can get it. It is worthwhile. It has been worthwhile to us, and I would encourage you to explore it.
Great. Thank you so much, Nick and John. Can we get a round of applause, please?
Thank you. Thank you.
I'm going to welcome on our next two speakers in just a moment's time. I'm going to welcome on Dr. Jeffrey Graves, the President and CEO of 3D Systems, and Patrick Tracy, Founder and CEO of Oncos Surgical, to the stage. Thank you both. So we're going to have our second fireside chat today and take the conversation a step further. But I do want to start with both of you also at the very beginning as well, just to give people a bit of a sense of where this collaboration, where this journey started. So when the two companies really came together, where were you at in your journey? What was going on at the time?
Well, I'll let Patrick comment on when we started to be engaged. Our history, 3D Systems, our history with 3D printing specifically for the healthcare industry goes back a couple of decades. So starting with producing medical models to assist surgeons in their planning in the hospital, to moving that into the digital environment with planning more real time and working with our engineers. And then finally, as the technology evolved, being able to print surgical aids to assist them in the execution of the surgery, and then finally ultimately implants. And along that path, we got to know Oncos and Patrick's company, and it's been a great relationship for years.
Yeah. So it's kind of interesting for us that where the relationship began and the journey was literally at the beginning of it. So we had the concept to found Oncos, and we started the company because there was a lot of focus on orthopedics. So we're essentially an orthopedic implant company, but there was a lot of focus at the time in what's referred to as primary hip and knee replacement. So probably everybody in the audience knows somebody who's had a hip replacement or a knee replacement, and there were so many patients entering the episode of care for hip and knee replacements that some of the more complex patients and requirements in orthopedics had really been left behind. So when we decided to start the company, we realized that we did need a partner in 3D printing. I think one of the previous speakers had mentioned that for companies like ours, 3D printing is a means to an end, and it very much isn't the things that we do in complex orthopedics. So we literally, the day we opened our doors, had a strategic relationship with 3D Systems, and it allowed us to jumpstart the company, go fast, and it's been a great relationship ever since.
Sounds like one of those dating app commercials, right? I was first attracted to Patrick's company.
And so I want to talk about applications specifically then. So Oncos is focused on delivering patient-specific solutions for patients with cancer and really complex orthopedic conditions. So can you just share a little bit with the audience about the specific application areas that you're actually working on using additive?
Sure. Well, there's quite a lot actually, but one of the things perhaps that we could talk about is not even so much, I like to think about it is more than just 3D printing, but almost the digitization, if you will, of healthcare. There are so many things that we can use with the data that is currently available to us that really just wasn't available, say, 15 and 20 years ago. I don't want to say what year I started in my career as a young mechanical engineer, but we used to work with model makers in a tool room making brass patterns. Then came parametric design software, right? So, but when you look at how these things are being applied to healthcare, it's almost ubiquitous now that more complex patients do obtain sophisticated imaging. So when you look at the improvements in the imaging modalities in MRIs and CT scans, that data is very, very powerful to use further on down the process in design and both manufacturing. So much so, and it's kind of interesting when you think about it, but I don't know, when is the last time anybody has heard the term exploratory surgery? Right, we used to hear that a lot 20 and 30 years ago, but now with all of these improvements in imaging modalities, it really doesn't exist. So we'll use that data along in partnership with 3D Systems to recreate the patient's anatomy. So we take that data, recreate it in a computer, and then work with a surgeon to design a specific surgical plan for that patient. And one of the things that's very, very powerful is the ability for that surgeon to preoperatively plan the removal of a tumor from the bone. Years ago, when X-rays were things that were on film that you could hold, you couldn't do that ahead of time like you can today. So it's the preoperative planning with the digital information we have, and then how that can be used to design, like literally the tools that the surgeon will use to precisely excise that diseased tissue.
Mm-hmm. So you talked a little about the before printing side of things there then. And Jeff, I know you mentioned it at the start, but can you actually just chart us a little bit more of a path of where 3D Systems has kind of grown with this specific application area?
Sure. And I love the way Patrick put it. It's really not about 3D printing itself. It's about bringing a better solution to the patient faster and more efficiently. Mm-hmm. Our journey personally started out with helping physicians turn these digital images into a physical model that they could hold to plan their surgeries and also explain to patients. That was 20 years ago, and it still exists today, but more and more, as Patrick mentioned, it's moved into the digital world with more advanced imaging and more sophisticated computer technology, so that not only can patients understand their disease state, but the surgeons can actually plan the surgery in much more detail, and as an integral part of that, design surgical aids to go faster and better through the surgery for improved patient outcomes and better economics. So along that journey, you've got the imaging piece that Patrick mentioned, you've got the ability to 3D print complex objects in metal and polymers, both, to specifically fit a patient outcome. And then increasingly, we participate in the actual implant of a replacement part of the bone or something of that nature. So it's been a marvelous journey over 20 years. I think our patient count now is up over 200,000, and roughly 2 million implants actually have been used. They're all require FDA approval and CE marking in Europe. So it's come a long way. To Patrick's point, it's a tool in the toolbox now. It's not a specific activity that's a set aside, so it's marvelous. And I think that goes for 3D printing as a whole, but certainly it's becoming an integral part of healthcare now.
Mm-hmm. And as you both said, it's not necessarily just about 3D printing, but I do want to understand, how did you start to really approach this application with 3D printing? What were the challenges that you were really trying to overcome with this technology?
So again, I think for us in orthopedics, when you look at orthopedic surgeons, so many of them that you speak to will tell you that they wish they took more woodshop classes, than perhaps physics classes, because it's carpentry. It really is carpentry of the bone, and either removing bone, shaping bone. So you've got the tools that the surgeons use, or the instruments, but also the implants, right? So when we look at the advent and the improvements, particularly in metals printing on the implant side, we can do things today that really, again, couldn't be done years ago, from both a patient-specific aspect, and again, I enjoyed the previous speakers about how the technology allows you to build things for bone ingrowth, et cetera. So it's really twofold: one on the instrument side that the surgeons use to shape or remove the bone, and then the other on the implant side.
Mm-hmm. And coming to 3D Systems, I know, what were your initial thoughts of approaching this particular case?
Well, it's a marvelous example and application of digital imaging technology combined with the technology of 3D printing to solve something. And I would tell you, it's not only a wonderful business to be in, but the ability to touch patients' lives. And Patrick's got some lovely examples of salvaging patients' limbs from oncology cases. They have cancer, and suddenly the person doesn't have to lose a limb. They can do it. On your worst day at work, you can walk around in this sea of 100 engineers in our building working with surgeons real time and say on the worst day you have, you've touched somebody's life and returned functionality to them and improved their quality. So it's been a marvelous journey. It's a great story of both creativity, but also improving the precision of technology and the material usage, but also bringing the cost down to where it's affordable and available to surgeons around the world now to apply to patients.
I'd love to understand a little bit more about the workflow for this then, and I know we've got some slides to help illustrate that. Could you both talk us through the workflow?
Sure. Well, it might be good to go to the slides now if we could get those queued up for the audience. Okay, so this is a particular case where we use, again, the digital technology for making the instrumentation for the surgeon to remove a disease. What you see in the upper left, that's a cross section. It's a CT. It's one slice of a CT scan of a knee, and if you look sort of what's facing to your, well, that way. Is the kneecap, the sort of dark spot between those two areas, horizontal, that's the knee joint. But what you see on there is on all the way to your right is what looks like a white, fluffy, cottony area. And unfortunately, that's cancer. And when you look at bone cancers, that start in the bone, primary bone cancer. As far as overall cancers go, it's very rare, probably less than 1% of all cancers, but it's a very common cancer, unfortunately, in kids. So it's one of the more common cancers behind leukemia in kids. So really is, unfortunately, a disease of adolescence. But so we would get those images from the surgeon and then enter what we refer to as our My3D process, and we would work with the surgeon, reconstitute a model, so a three-dimensional model of the patient, which you see in the center up there. That's the end of the thigh bone or the femur, and the magenta or red color there represents the tumor. Just to the right of that, then we would work with the surgeon to say, okay, where would they want to remove that disease? And you can see those planes, and that's a 4 planar cut there to remove just the disease. Now, so many of you that are experts in 3D printing, back to it's sort of a means to the end to appreciate what this means. Yes, we're printing, ultimately what you see on the bottom, a small plastic guide that's designed, but if you look back at the 70s, in the 1970s, someone who was diagnosed with that disease would have had an amputation. So they would have had an above-knee amputation and they would have lost their leg. In the 90s, we were able to start to make implants to replace them. They were investment cast, right, as the Egyptians have been doing for thousands of years. Not very strong, not very accurate, and it was a big metal implant. We then moved on, we 3D print some implants now, but there's nothing better than with this precision to be able to remove just the cancer. What you see in the lower left there, again, for the workflow, now, that bone that's removed needs to be replaced with something, right, that won't fill back in and heal on its own. So what most surgeons prefer to do is use a donor bone, or a cadaver bone that would have been donated. And what you see there in gray is an overlap preoperatively now. So an overlap of what that donor bone is going to look like and how it would fit that, that defect that was created surgically. Now, that again is very, very powerful because the way this would have been done previously is the surgeon would have gone into the operating room, worked by hand to remove it, if it could even be done, because these can be very, very complicated cuts. Then they would have that donor bone that they hadn't seen before, unwrapped because it was frozen, shape it, whittle it, carve it for hours to make it fit. So we can lay that out ahead of time, and then you can see how it fits there. And with that, it is amazing. I understand there were some discussions yesterday about voice of customer. And it's amazing what your customers will tell you if you listen to them, and you can share with them what they can actually have. So we wound up, same time with this relationship with 3D Systems to make the guides, we put together an arrangement with one of the larger bone banks in the country to launch the world's first commercially available virtual bone bank. So now the surgeons can look at these bones before they get in the operating room, see how they're going to fit, and then we work with the 3D Systems engineers along with ours to design the cutting tools. So what you see to the right of that bone, again, that's the guide that's designed for a surgical saw to remove the bone. Then we make a holder in the guide to remove the bone that will fill it. And then you can see on the right how that looks like. Now, this is all before the surgeon goes into the operating room. So a little bit bigger pictures. That's the tumor at the end of the thigh bone, in the back of the back and side of the knee. Here's what the surgeon would see the defect. Now, the surgeon will tell us how far away they want to cut from the tumor to be safe, because you don't want to leave any tumor cells behind, and that's referred to as a safe margin. So you can see what that would look like. Here's where we work with them with that virtual or digital bone bank to overlay on the screen there. This is what the design of the guide looks like, the red tissue being removed. This is the cradle, if you will, for the donor bone and what that's going to look like. Now, this next picture, this is very powerful, and it's quite, crazy how well this works. When you look at post-op x-rays, they look like they're photoshopped because of the precision that you can do in 3D printing the guides, and they sit very, very firmly on the bone, right? They fit to the surface of the bone, and they basically lock in to one place. And so here's what the surgeon would see before they even got into the operating room. And just the last slide we have here, so that's the tumor before, that's the planned removal, and then what the surgeon sees is the bluish is the bone that's replaced. Last thing I guess I would leave with this, we are, I think I heard it earlier too, sort of techno nerds, and we love the technology, and we try to impart that enthusiasm to our customers. Well, often we will have the customers the surgeons speak to our engineers after a case. We can always learn something, and we love to get that feedback. And there was one particular case, there was a surgeon in Denver, and she had a very, very difficult case, and our engineers were asking her, well, what was different? And they were fishing for, it was so accurate, or the guides fit so well, or like something about the technology. And her response was, you know what, I slept really well the night before. And it's because she was able to think through the entire case before she even got into the operating room. So it really, really is very, very powerful technology on so many fronts with really the overall digitization, if you will, of the process.
So you can imagine that what Patrick just described, the improved outcome, patients no longer lose limbs often with this approach, the dramatically reduced cycle times in performing the surgery enabled by this imaging and pre-planning, and the surgical aids used during surgery. Marvelous advancements. And cost, we often talk about improved patient outcomes. Cost is really important in getting this healthcare distributed around the world, because now it's becoming more and more affordable for surgeons to actually apply this technology.
Mm-hmm. It's an amazing application story, and as you mentioned earlier, the age group of patients that this is really affecting is just quite remarkable. I think it makes the story even much more meaningful, and as you say, not just the patient, but the surgeon as well, it's impacting their lives too. So what has been the impact of this overall collaboration then from both sides? Would you say it's the technology is driving application, or is it the other way around? Is it a bit of push and pull on both sides? What's that been like?
Oh, I think it's highly interactive. It's on the one end of the spectrum, it's the surgeon that has to treat the patient, and the oncologist, that teamwork. But the advancement of technology in parallel, these guys are often not technologists. They're very bright people about medicine. They're not technologists. So companies like Patrick can help bridge connecting with the technology that they understand very well with a clear patient need, bringing that together for a solution and packaging it for the surgeons in ways they can apply very simply in the OR.
And what would you say from your side?
I would agree, and great reminder by Jeff that it's not just about outcomes, which is obviously very, very important. But if the affordability isn't there, then you really can't get market adoption. And again, to put that in perspective, a surgery like this may, without this technology, could take 3 or 4 hours to do, just to shape the allograft, if you will, or the donor bone, and that can take that down, to maybe a half an hour, where it's estimated the cost in operating rooms could be upwards of $800 a minute, right? So that's real savings to the healthcare system, not to mention the outcomes. And the relationship, it really is cyclical because we learn, and that's why we ask customers after every case, how did we do? What could we do better? What could we incorporate? And we are not on the absolute forefront of 3D printing technology. That's where we rely on the relationship with 3D systems.
Absolutely.
So again, for us, it's very much a means to the end. And when we can get things that are maybe different materials that are better suited for something, or models that Jeff had mentioned, or implants, we rely on that relationship with 3D systems.
Jeff, you had some extra thoughts there.
No, I agree with everything Patrick said. The neat thing too is the feedback loop into our R&D activity. We're developing new materials. We've moved from metal printing for repair of the bone structure, if you will, into now advanced medical polymers. So, and with that, bringing printers along so that they're basically a small clean room environment. So you can print actually at the point of use. We're doing more and more providing of this technology to hospitals themselves so they can start applying it real time, which broadens the spectrum of indications you can address. Patrick mentioned cancer, clearly a significant issue with bones. There's also the whole trauma aspect, that the closer to the patient you can become, the more bone-like material you can print, you can start addressing trauma cases, so it really broadens the use application. So the feedback loop's really important in the R&D stage as well, and what we're going to do for the future.
I did want to touch on that as well, because I know 3D systems, you of course operate across the whole value chain, materials, software, and the printers themselves, and you've got these strategically placed manufacturing sites across the US. Is that part of that, so bringing this technology closer to where the end user needs them, and what kind of impact does that have on the patient?
Well, two areas. Number one, its response time is greatly improved the closer you can be. So step one in that, which we did years ago, was to be multi-continent. So we have facilities in Europe, we have facilities in the States and elsewhere. And the next generation of that is actually moving into the hospital itself, which we're starting to do now. So that's really important. With that comes a lot of requirements in terms of cleanliness, ease of use, all of this, in addition to the advanced materials you want to print, and making the systems smarter and easier, because again, surgeons are not engineers, right? They don't want to be engineers. They want to be able to basically automatically take an image and then print a solution if they can do it, and along with it, surgical aids to enhance the speed of the process. So getting closer and closer to the patient is an absolutely essential evolution of the technology, which is yet to come, but getting closer every day. And many people bring up AI these days. Certainly Patrick mentioned the advanced imaging technology that's used. It's magnificent. You can detect cancer much earlier, things of that nature. Dealing with that data and turning it into useful information rapidly without the intervention of an engineer is really impactful from an AI standpoint. And it's, again, another evolution of the technology.
Jeff, I did have a question for you about that, because I know on last year's panel we talked a lot about AI and the impact on additive manufacturing, but can you just go into that a little bit more deeply about what you're working on right now and how that is impacting the healthcare sector? Just
focusing on healthcare, and you could talk about it in many different avenues, but in healthcare specifically, most people, again, whether we've seen images of grandchildren and things compared to, I look at what my children's images were years ago versus modern technology. Imaging technology is so advanced now, but the amount of data that produces is enormous. So having intelligence, having AI to help process that data can, number one, find defects, find cancer at an earlier stage, things like that. But it can also very much reduce the engineering time. If you look at the surgical aids that Patrick mentioned, you can dramatically reduce the engineering time required to turn a digital image into a surgical aid. The brain of the surgeon is still needed to plan the surgery, but then generating the surgical aid itself, through AI, you can dramatically reduce that cycle time. So again, you can get cost, you can introduce automation, you can get cost out of the process, and make it easier to apply in the hospital. So there's no better application of AI for our company right now than in healthcare.
I do want to ask you both as well about the regulatory aspects, because for these guys, they're specific to the patient, and these are very real parts affecting very, very real lives. What has been your experience of the regulatory process? And I guess, Patrick, as well, how challenging has it been to implement a new technology, new process like this into the healthcare space?
Yeah, and again, listening to the previous speakers, one of the most straightforward ways to bring something through FDA is when there are guidance documents and guidelines in place. When there's not, it can be far more difficult. But I also enjoyed some of the comments in that the thing we all have to remember, the folks at FDA, they have a big job. They have a very, very tough job. Their job is to protect the public health. And within that, I've spoken to some senior levels at FDA where maybe something didn't go right out in the marketplace, and they had told me, you don't have to testify before Congress but once, and you don't want to do it again. So they're in a tough position. If they let something on the market maybe that doesn't perform the way it was intended, they're bad guys. If they take too long to allow something on the market, they're bad guys, right? But they're not. They're good people that have the same goals as we all do, and they go to work every day trying to do a great job. So I found in personal interactions with FDA, we've got to be a little bit empathetic. They have a very hard job. They do it very, very well. And but sometimes, and it's not necessarily, if you will, their fault. If there hasn't been a pathway, if it truly is a new technology, not just say in 3D printing, and if there isn't the guidance in place, it can be a little bit more difficult. But I do think over the last several years, with the guidance documents, how you validate, again, things where it's printed on a plate, power, time, et cetera, it is more straightforward.
And Jeff, do you have any thoughts on that, on your experience as the OEM side?
It's very easy to get frustrated when you develop a new technology and you know it brings benefits to patients in principle. It's very easy to get frustrated with the time it takes to get through the FDA or the European regulators. To Patrick's point, it's extremely well intended. It's meant to protect the public. And yes, you just have to work it, and you have to know the process, know the people, have an advanced dialogue many times with them, and work it through the system. It's cumbersome, it's difficult, but it's necessary, and you just get through it as fast as you can. And it often takes as long to get regulatory approval as it does to develop the new technology, or even longer, quite frankly. But again, it's targeted towards safety of the patients.
This particular application, do you feel like this should be the blueprint for how things are done going forward? And is there a reason why it's not, perhaps? Is it too challenging, or?
Oh, I think it's a marvelous example of how well it can work. You think of the workflow, the value chain that represents from the surgeon to the smart person that's trying to put together these technology tools, all the way to the technology developer. That iterative process through and that real-time dialogue, fantastic. It's absolutely the way it should work. And in healthcare, it's an integral part of the process by nature. I think it should be repeated in every industry, and where we're most successful, it is repeated. So that's my belief, Patrick.
Yeah. So I know. For probably those in the audience, there's been a little bit of a headwind maybe the last couple of years on the industry and additive manufacturing, but from someone who has seen the power of this technology, I don't know, maybe it's like those of us that aren't very good golfers, you hit one good golf shot and it brings you back. If I could share anything with the folks in the audience.
Never had that experience, Pat.
You're a very good golfer.
I'm consistently a bad golfer.
But it really, really is powerful technology, and where we do see healthcare and the industry going, healthcare in general, I would say overall, personalized care is not going away. And whether it's from the study of the human genome and specific targeted therapies or drugs, it's not going away. When you look at orthopedic implants and orthopedic care, going back to, again, maybe the 70s when hip and knee replacements really were coming into the modern era, everything was made ahead of time, everything was put on the shelf, and there are many, many, many hundreds of millions of dollars in cost and inventory that's sitting out in hospitals with implants. Now, not every patient needs a personalized implant, but far more could benefit than are currently getting the technology. And as times come down, cost is reduced, there are going to be far more benefits of a personalized implant. And the thing that's really powerful about it is, again, today with all of that inventory, a surgeon may need to do, say, a hip socket, and they'll pick through a bunch of different bits and bobs and doodads and figure out how it all goes together in the OR, whereas we can take that all out of the OR, print one piece, so one SKU. We can essentially have an infinite number of SKUs with zero inventory, right? That's very, very powerful. We just have to get to the point where we can deliver that in time, where the surgeon can always rely that that implant is going to be there when they need it for surgery.
I do want to make sure I leave you with both some time for some final thoughts. So I just want to get a sense, similarly, of your optimism at the moment. I'm guessing it's pretty high from everything we've just heard right now, but how are you just feeling at the minute about the levels of adoption for this technology? What's kind of keeping you inspired every day to come to work and keep working with additive technologies?
I get inspired to come to work and work with Jeff.
We're back to that dating app thing. No, it's a marvelous relationship. You develop very close relationships when you work with people over the years to bring such technology to individual people's lives. It cannot help but touch you. It's very, very moving. Another exciting aspect, though, is where it can go. When you think about what the changes in surgery that this has enabled and the impact on people's lives, and you think, okay, how do I make it faster, better, even less expensive? Can we begin printing bone replacements? Can we move from the skeleton into soft tissue? Can we ultimately move into organs through regenerative medicine? Can you help the body regenerate itself? That is mind-blowing technology that's not far into the future. Quite frankly, it's evolving very quickly. So I love the work that we do today, and we're getting it in the hands of so many more people now. To Patrick's point, it eliminates inventory and costs in the hospitals. It brings solutions faster to patients, and then the evolution of the technology, where we can go in helping the human body survive and live longer, and improve the quality of life as people increasingly live longer. How do you improve their quality of life, their mobility, their resistance to disease, and their recovery from trauma? It's amazing. You can't help but feel really good about it.
And in the last couple of minutes then, any final thoughts for the audience today? Any kind of key words of wisdom for them to take with them into the show floor this morning?
Well, I would say I was thrilled to be a guest and be able to share, with folks that are, such experts in additive, how it can be applied to truly, make the world, a better place. And I'm super optimistic about what the technology means for the orthopedic field, for the healthcare field in general. And for us, we've got to focus on going faster. And for us, that speed isn't often how fast the laser dances across a plate, right? That's not really it. It's almost like everything around it. And we challenge our team all the time on the speed side that, until we are violating the laws of physics or the space-time continuum, how do we go faster? And I think that's something that we have to figure out. How do we work better with the hospitals, with the surgeons, and with our 3D printing partners to really tighten that up? And it's really not a lot about the actual printing itself, but really the ecosystem that it fits in. So I'm really optimistic there. We're seeing a lot more work being done in this area in healthcare, so I'm sure it's going to continue to make great benefits for patients.
Well said. I think the entire field, when you look at 3D printing in general, it's migrated from the machine technology and materials you can produce into specific application areas. A fast migration, and it's a wonderful migration because that really enables the technology to come to a point around applications, and that'll in turn drive these improvements. So as you walk the floor, every booth, I'm sure, is highlighting how is this technology used as much as how does the machine work, right? And you'll see that increasingly going forward. Okay.
Thank you so much, Patrick and Jeff. Can I get a round of applause, everyone?
Thank you. Thank you, Patrick. Thanks.
And thank you so much for listening.
Please welcome to the stage Vice President of Integrated Media SME, Jake Volsko.
So yeah, this industry is fascinating. I've been with SME for about 2 years, and this stuff, it just completely blows my mind, and I'm just proud to be standing in front of all of you. I'd like to thank Laura and all of our panelists this morning for the insights that they shared. Please join us back here at 1. We have another Executive Perspectives panel planned then. There's also one at 8:30 tomorrow morning. Just as important, tonight at 5 in this ballroom, we'll have our AM Industry Celebration. Please be sure to join us. And now, I think you all know you're at the premier event in the industry. So please, the show floor is open. Get out there, visit our booths, and have a great day. We'll see you soon. Thank you.